Why do our teeth chatter when we're cold? That's a really good question. You don't even need to say it, right? Let's go to the next one, which is also really good. Iber, I think it's a silly question. I always fall for this bait. If someone writes that the chance of me answering is much higher, all right. But usually the question is really good. Check it out. Why does the conductor keep making those movements with that little Baton? The name of the conductor's little stick is called batuta. And when I looked it up, I found out that in English the name is Baton. And yes, it has everything to do with the lipstick people put on their lips. Because in French, baton means stick, and both the conductor's baton and lipstick here in Brazil are stick, just in different shapes. But what is it for? Is it just to look nice up front? No. First of all, it's to mark the speed of the music, the tempo of the music. So a violin can't play the music faster than a flute, otherwise things get out of sync and become messy. But that's just a basic function. There are much cooler features. The conductor can, for example, help a musician come in at a specific moment that's kind of difficult. So he knows that moment is coming, looks at the person, and boom, and he knows that. But thinking artistically, what's really most important is that the conductor brings the music to life. So, for example, he'll look at someone and show that that part needs a lot of emphasis. Or he'll look at someone else and say, no, now you lower it a bit here, so we can create some tension, create a calmer part. You're going to build suspense, keep building, and now you bam. Come in with everything. All of this will make the orchestra not play mechanically, but play with much more emotion. If you watch closely, you'll notice many conductors don't use a baton and just use their hands, while those who do use a baton also rely on their eyes, body movements, and their other hand. So there's a whole dance, which is a form of communication that the conductor is having with the musicians, and it has to be silent. After all, you're listening to an orchestra. It's a nonverbal communication. Are there giant snakes like the anaconda from the movie? Anacondas do exist, and they're the largest snakes in Brazil. But here, we don't usually call them anaconda. We call them sucuri. If you want to see one in person, there's one nearby at the Baton Institute. Is asking if the snake at Baton is stuffed or alive. No, it's alive. It's in an aquarium there. Since it's alive, you might get there, and it could be hiding, but it's alive. This snake is found across Brazil and nearly all of South America, wherever forests exist. And one very interesting thing about the anaconda is that it kills its prey by constricting, strangling them. It squeezes until the animal can't breathe anymore. There are some differences from the movie. The first thing is that humans are not part of the anaconda's menu, so it's not like it desperately goes after people. Maybe if you suddenly swim next to an anaconda and it sees you, I don't know if it'll like that, but it's not an animal that goes running after people. And to answer your question, it's not as gigantic as the one that appears in the movies. We did some research and found out that they estimated the anaconda that appeared in the older movie was about 12 meters long. I don't know if the one in the new movie is the same size, but a real anaconda will reach, at most, about 7 meters. Usually they're much smaller than that, around 5 or 5.5 meters more or less. But hold on, because in the past, there really was a cousin of the anaconda that was huge. And here it is. Look. In our book of dinosaurs and prehistoric life. Yes, we just released this beauty. And this book is actually also a companion to Mysteries of the Universe. So, if you have Mysteries of the Universe, you already know it's an amazing book. This one is also incredibly beautiful. Let's find the cousin of the prehistoric anaconda. What a beautiful book. Let's be honest. Come on, it's for you to learn endlessly. In that hands-on way, having fun without getting tired. And where is our friend here? Look, what's cool about this book is that you always have a photo of the fossil and a drawing of how we imagine the animal to be. Here it is. Titanoboa, 13 meters long. In other words, more than twice the size of today's anaconda. And such a robust body, it wouldn't fit through a door. Titanoboa was a terrifying snake that lived in the swamps of South America about 7 million years after the extinction of the non-avian dinosaurs. That extinction that killed almost all the dinosaurs. It wasn't venomous, but that didn't matter much to its prey. It was a constrictor, crushing them with the strength of its own body. Maybe those anacondas from the movies are based on this one here. If you want to know the price of the book, where to buy it, and everything else, the link is down below. And yes, there will be a launch soon. Let me check my notes here. March 28th, a Saturday in Sao Paulo at 11 in the morning at Galeria Magalu in Conjunto Nacional. If you're from Sao Paulo or the area, it's on Avenida Paulista. It's really easy to find, really easy to get to. If you want more information, like how to get a ticket and everything else, I'm leaving the link to Galeria Magalu's Instagram profile down here. Then you can talk to them. All right, Iberê. How do planes with banners, usually with something written on them, take off? Wouldn't the banner tear? I didn't know the answer, and it's really cool. These planes here in Brazil, you usually see them at the beach. You're there on the sand, and the plane flies over the sea. So everyone watches the plane advertising something, and it's a huge banner, right? A huge banner that it carries on its tail. And really, right, it must be hard to take off with that. The problem isn't tearing. The fabric of these banners is usually very strong, so it's likely it won't even tear. But it's really hard to take off with that tail. That huge tail flapping in the wind. That's drag, right? It's like a brake. It slows the plane down, and it destabilizes the plane during takeoff, which is one of the most tense moments. So the truth is, the plane doesn't take off with the banner, and the banner isn't inside the plane, and the pilot doesn't throw it out. No, the banner stays on the ground. Then they set up two poles, usually with a wire in the middle. That wire is attached to the banner. Then the plane takes off. It flies low near that wire and drops a hook. That's what I saw. It was a grapnel, okay? A grapnel is a set of hooks like this. He drops a grapnel, and the hook snags on that wire and takes the banner. So the plane kind of fishes the banner while flying. And from what I researched, it's a hassle for the plane to carry it. Like, it uses more fuel. It's hard to fly with that thing. And when it's time to land, you'll have the same problem. Landing is another tense moment. It wouldn't be good to have that thing fluttering behind. You know what he does? He drops the banner right before landing. So he lets it go, and then he lands smoothly. Is it physically impossible to lick your own elbow? I was going to look up what the physical restriction is that you have, right? What is it about the arrangement of the bones and muscles that makes it so we can't lick our own elbow? But then I mentioned this here on Manual do Mundo, and I found out that Daniel, who's a physics intern who just got here, can actually lick his own elbow. So I'm going to invite Daniel to come here and show us. Check this out. Daniel was selected for this internship position because he's someone who communicates well. He's a very smart guy, a really nice guy. But now, he's going to be known all over the world for his ability to lick his elbow.
That's probably the most important ability, right? Among those you mentioned.
Tell me, when you were in school, did everyone know you could lick your elbow?
No, I don't think so. Actually, there are a lot of people who have known me for a long time and have no idea I have this skill.
So later on in other videos, we'll get to know all these other skills of Daniel. But for now, we're really interested in finding out if it's physically possible to lick your elbow. So what do you think?
Let's do it. All for science, right?
Okay, but hold on. Let's break this movement down into two parts. First, you have an ability to bring your elbow close to your mouth that I don't have. How close can you get it?
Up to here, more or less, I think.
No, man, no, I can't do it. Look, you can make the tip of your elbow line up with your chin, like this. Wow.
I think it's more on my shoulder. My shoulder goes back on that.
Oh, my shoulder just had surgery. Now let's try with the left arm. Yeah, no.
No, but you almost get there.
Yeah. You almost get there, but there's also a tongue issue, right? I think there is. There's a tongue issue. Yeah, it's a mix of flexibility and tongue reach. So, he's not a physicist or a physics intern because he hasn't graduated from college yet. But he's close. He proved that it's not physically impossible.
I'm not sure if you can train it, since I've never done so myself.
You were just born like this, so...
I believe I was born with this gift.
Has this gift ever helped you achieve something special in life?
Appearing in a Manual do Mundo video, I think that was good enough.
Thanks, Daniel. Just to show that it's not physically impossible to lick your own elbow. My name is Valentino. I'm 12 years old. Give a shout out to my brother Emmanuel. Hey, Emmanuel, a shout out to you. I have a question. Is green coconut the same as brown coconut? Or does green coconut turn into brown coconut? Is that what happens? Exactly, Valentina. The green coconut is the same as the brown coconut, just earlier. It's less ripe, so when you open the green coconut, you notice that its pulp, that white part, is still very thin. It's still forming, and there's a lot of water. In the brown coconut, you'll already have a much thicker pulp, which we use to make beijinho, to put in desserts and so on, and a little less water. An interesting thing is that as the coconut ripens, it stops being green, turns yellowish, and then brown, and that thick husk around it, which you can see really well. When you cut the green coconut, it starts to crack, it starts to break apart. And the coconut we buy at the supermarket, you can notice that it's already much smaller because that outer husk has been removed and we can only see that harder part that's surrounding the white part of the coconut. So the brown coconut in the end is basically just the innermost part of the green coconut. All that thick husk has already been thrown away or used for something else. Which parts of the human body keep growing even after adulthood? Let's disregard nails and hair. And yes, a lot of people will immediately say nose and ears. And that's true. They do keep growing even after a person becomes an adult. And it's not because the cartilage, that structure we have inside the nose and ears, it's not because it keeps growing nonstop. No, the truth is that the cartilage starts to get softer and looser. So the structure that supports our nose gets weaker, kind of like gelatin, and it starts to droop.
Gravidade vai agindo no...
The nose and ears, and this makes them droop, sag, and get bigger over time. Question from Rafael Ciendido Iberê. I would like to know how acid rain is formed. In the current Iran war, the United States bombed an Iranian oil depot, and it caught fire, releasing black smoke that covered the whole area. The Iranian government issued an acid rain warning. What is that? Is it the kind of rain that hurts people? Is it a rain?
A gente deveria ter medo dela? Sim e não.
Acidic. It's rain that's a bit more acidic than regular rain. For it to affect a human being, it has to be very acidic. Maybe that one in Iran is dangerous, but that's not usually what happens. When we burn certain things, especially oil derivatives like diesel, gasoline, or coal, we release some sulfur and nitrogen oxides into the atmosphere. Sulfur here is S and nitrogen is N. This is basically a type of pollution that we create, okay? And then when it rains and the water comes into contact with these oxides, it reacts chemically and forms acid. It will mainly form sulfuric acid and nitric acid, which are very strong acids. But this isn't going to rain down pure. It will be diluted in the water. So, it's not like you're going to walk out your front door and start melting as the rain falls on you. What happens is that the rain contains a bit of these acids. It doesn't harm your skin directly at that moment, but in the long run, it causes problems that just don't end. So, first in nature, when it falls into a river, it makes the river more acidic, makes the soil more acidic, and harms a lot of plants and a lot of fish. In the city itself, as the acid comes into contact with the metals in buildings, it causes damage. In Minas Gerais, for example, the statues were greatly damaged because of acid rain. So you don't need to be afraid of acid rain, but acid rain over
O tempo causa bastante problema. Por que a bola?
Is there a reason why a classic soccer ball is white and has those black parts? Yes, there is. In the 1970 World Cup, which was actually won by Brazil, Brazil became 3-time champions. A lot of people consider that this was the best Brazilian team of all time, or maybe even the best team of all time from any country. In that World Cup, FIFA called Adidas to make the ball. And then FIFA decided to get inspired by an inventor who
Chamado Buckminster Fuller.
used to build some geodesic domes. If you have no idea what a geodesic dome is, it's this right here. Look, they are spheres, or sometimes just a part of a sphere that are built from geometric shapes. Here, it's built with a triangle. But if you break down this triangle, right, you can see pentagons, hexagons here. You can see other geometric shapes made from triangles. So this classic ball, it has, look, 32 panels. There are 12 black pentagons and 20 white hexagons, forming what's called a truncated solid. The name of this geometric form that mixes pentagons, right, which are these 5-sided figures with the hexagons, which have 6 sides. The official name of the ball was Telstar, from television and star, because it was a star on television, and those black spots on the white ball exist precisely because of television, which at that time was still mostly black and white. And that's why you needed some contrast there to be able to see the ball. If we were to make a timeline of soccer balls in the beginning, they were usually the color of the leather itself, brown, kind of reddish. Then, in the 70s, they started to have that pattern with black patches. From a certain point on, the balls started to be white, but with colorful designs, because nowadays it's much easier to produce a ball, and TV no longer has so much trouble showing it. By the way, it's a World Cup year, and I think it's worth showing that video taking apart this year's ball, isn't it? How does the CIEP system work? The term CIEP comes from the Portuguese phrase for postal addressing code. It's an 8-digit code, the 8 numbers that the postal service uses. to know where to send a letter when you put it in the mailbox or when you hand it over to the post office. This number doesn't have your exact address, it's an approximation. Sometimes it's a street, sometimes it's a building, and depending on the city, it can even be the whole city if it's very small. In my hometown, there's just one CEEP 18170, but this number was created because when you get to the post office with a huge address like Avenida Magalhães de Castro Alves da Silva, number 357, in the Iparanga neighborhood of Santo Antônio da Cachoeira da Paraíba, it's complicated for this post office, and then for the other offices that receive the package, to know exactly where they have to send each thing. So, here in Brazil, in the 1970s, they invented CEP, which at the time had only 5 digits, to help with this job. Let's take a real number. Then, 1, it's the countryside of Sao Paulo. So, the moment someone mailed a letter there in Manaus with this number here, they already know, oh, this goes on that plane heading to the countryside of Sao Paulo. Alright, when it gets to the countryside of Sao Paulo, they'll look at this second number. It means it's in the Campinas region. So send this letter to the distribution center there in Campinas. When it gets there, they'll take a look at what comes next. This 1 means it's actually in Campinas or in a city very close by. The 6 means it's in the city of Engenheiro Colo, and from here on, it gets more and more specific. But just with these 4 numbers, we can already get the letter very close to where it needs to be. So in the end, the CEP doesn't have the
Exatamente com coordenadas
geographic coordinates with a code where you know exactly where the person is, but with the internal system of the post office to know the best way to route those packages. How does a pen write in space? You've probably heard a story that NASA spent millions and millions of dollars to develop a pen that could write in space, while the Russians simply used a pencil. That story actually sounds like a joke, because it really is. It's not true. Pencils aren't used in space. Even here on Earth, pencils have been around for a long time. They make a mess, they shed graphite, and the tip breaks. When you sharpen them, you end up with a bunch of little pieces of graphite and wood. Imagine all of that floating around inside a spaceship that's full of electronics and wires. It's not a good idea. The chance of causing a fire is pretty high. By the way, fire is something NASA really doesn't like. Right at the beginning of the Apollo missions, when the astronauts were still training and testing the spacecraft, there was a very serious fire in which 3 astronauts died. Later, they ended up naming this incident Apollo mission. So, when you see the numbers of the Apollo missions, this one will be number 1. Alright, pencils aren't good to use, but regular pens don't work either. Because regular pens depend on gravity. The ink goes down, then it reaches that little ball at the tip, and as you move it on the paper, the ball gets ink on it and transfers the ink to the paper. But if you try to write upside down, you'll notice that the pen will quickly stop working. And that's when they came up with the idea to make a pen that's pressurized inside, which pushes the ink. It's a regular pen, but its ink cartridge is more pressurized, like a spray, with gas inside pushing the ink. So in any position you're in, the pen will work. It doesn't need to be vertical. And then this pen works in space. It works in a vacuum. It even works underwater. The most interesting part is that a private company, not NASA, created it. And in the end, it ended up being used by both the United States astronauts and the Soviet Union cosmonauts on the Soyuz spacecraft. Hello, Iberê, I'm Luis Miguel from Kikugawa, in Shizuoka, Japan. And I wanted to know why cardboard gets soft when you pour water on it. I can't answer that before looking up Kikugawa on Google Maps. Let's go. Kikugawa, Shizuoka. I guess Shizuoka is the state, right? Yeah, the province. I don't know what it's called in Japan. Oh, it's right in the center of Japan, between Osaka and Tokyo here, near the sea. Cool, huh? I want to visit Kikugawa someday. Paper is made up of a bunch of cellulose fibers, which is a material that usually comes from trees. Here, these fibers are all tangled up with each other, and there's also a force that attracts one fiber to another, kind of like that glue force I mentioned earlier. So, to tear cardboard, you have to overcome all of that, break the fibers, separate them from each other, untangle them. Let's take a look at this under the microscope.
Nah.
Wow. It's a messy tangle. It looks like fabric, a bunch of roots all twisted together. In fact, I can see several colorful things here. Kind of suspicious. Well, we've already seen in a Bravo how cardboard is made, which often comes from recycling when we did the Boravira there, recycling of Tetra Pak cartons. So, it's very likely that there's a lot of material here that's not just cellulose. But what really matters is the cellulose. It's these thin ones we're seeing. What happens when we add water? I'll use toilet paper for this because I think it'll look nicer and be more interesting to watch. Let's focus. Toilet paper has a texture that's hard to focus on because in the little holes of the texture, you lose focus. On the little bumps, you gain it. It's complicated. Let's go. I'm going to pour some water with dye here so we can see the water mixing with the paper. Wow, you can see it relaxing. But it's really hard to focus. You can clearly see that when the water gets into the paper fibers, the fiber softens, the whole thing relaxes, it gets soft. And this happens because these fibers have an incredible attraction to water. So both really want to stay close together. The water and the fibers really love each other. That's actually why the water moves so quickly through the fibers, it spreads out. Now, just imagine, at the beginning of this story, there were only fibers, each wanting to stick close to the other. And then, a troublemaker came into the picture. The fiber, instead of sticking to the other fiber, starts sticking to the water. So the water gets in between the fibers and they lose their bond. They lose that force that makes one stick to the other. The fibers become loose, and that's why wet paper loses all its structure. It loses its strength because that attraction that used to be between fiber and fiber becomes fiber and water. And the water is just sitting there in the middle. So the fibers come apart as if it were a
miojo colocado na água quente.
gas. Cutlery is made of metal and metal rusts. Why doesn't cutlery rust? Almost all the cutlery we use is made of stainless steel. Let's figure this out. Steel is a mixture. It's an alloy of iron and carbon. The carbon is there to make the iron harder. And inox comes from a word meaning it doesn't react with oxygen in the air. It doesn't oxidize, it doesn't rust. So stainless steel is a type of steel that doesn't rust. But up to this point, that's just the meaning of the word, right? Why doesn't it rust? Because besides iron and carbon in stainless steel, we also have chromium, Eld. And this little guy here reacts much more easily with oxygen than iron does. It's like when oxygen asks someone out and chromium responds right away, while iron takes a few days. So, in the end, oxygen will bond with chromium much faster than it bonds with iron. So, when we have stainless steel, oxygen, instead of reacting with iron, reacts with chromium and forms a layer of oxidized chromium, or chromium dioxide on top of the metal. And this layer ends up acting like a protective shield, which prevents oxygen from attacking the iron. But then, I know there are people out there who are going to ask me, wait a minute, when you scrape one piece of cutlery against another, doesn't this protective layer end up coming off? Doesn't it expose the steel again? And then it will rust. Yes, it will expose it, but then the chromium that's underneath that layer will react faster than the iron and will form another protective layer again. So this layer kind of regenerates itself. And that's the secret of stainless steel. Julia Casais? Sometimes we leave water in the bottle for 2 or 3 days. Is it just me? Or does the taste of the water change? Like, is it a problem to drink it? Is it healthy? Not really. That taste in the water usually doesn't mean anything good. There are 2 main reasons for that. First, the plastic from the bottle can release some substances into the water. And then the water, especially if the bottle is stored in a hot place, starts to taste like plastic. And the second reason is even worse, which is fungi and bacteria, Eld. When we open the bottle and drink water, a bit of saliva stays here, a residue that's full of microorganisms. Then you close the bottle, put the cap on, and store that thing. What happens to the microscopic living beings that were in your mouth and were left in the bottle? They can reproduce. Will it be healthy to drink that water? Because of the plastic, 2 or 3 days is a short time. Now, the bacteria can already cause some problems. You might feel nauseous and suddenly even have explosive diarrhea because of that water. So, in general, it's not a good idea for you to drink that microbial soup that's in that water. Ideally, you should put in fresh water and wash the bottle. I think everything is fine here, for now. Iberê, why is it that when we're in a car, the things that are far away in the background seem to move by more slowly, and the things that are closer seem to go by faster? Yeah, that doesn't make much sense, because the thing that's closer is going by faster than the one that's farther away. I set up a landscape simulation here. Okay, so this here is the background. It's the horizon that you see from the car. Those mountains that are already blue way back there. These 2 potatoes, they're mountains that are really close. And here, in the front, we have 3 animals. There's a leopard and 2 elephants. So, You're there on a safari in Africa, and this here is your car. Okay, the cell phone is going to be your car window, so look how cool that is. Let's start with this landscape here where we have, look, here's the leopard. Here we have a mountain, and way in the back is the horizon. This mountain, you can notice that it's right in the middle of your window, and the car starts to move. The car moves just a little, and the leopard has almost disappeared already. It's almost gone. This mountain, you can still see it normally through the window, and the background has barely changed. Then the elephant appeared. The elephant passes by, and you can still see the other mountain. And then another elephant appears. The elephant passes by, and that's when the mountain disappeared. But the background is still pretty much the same. So, yes, what you told me is clearly happening here. What's close to the window goes by quickly, and what's in the background moves much more slowly. Why does this happen? Let's understand how these distances changed, okay? I'm going to draw the eye. And here in front, we have the leopard, you know? My specialty is drawing leopards, right? Further back, we had a potato, and way in the distance, the mountains that turn blue on the horizon. If I'm in a car and I move this distance here, let's see how much this distance changed in relation to each of these objects. I'm going to measure with the ruler just so we can get an idea. Here, I was 4 centimeters from the leopard, and then I'm 12 centimeters away. The distance tripled. Look at that. From the potato, I was 25 centimeters away. When I moved, I went to 27. That's going to be 1.1 times. It's a very tiny increase. The mountains, they were 54 centimeters away. And after I walked, they went to 55 centimeters away. The increase in distance is ridiculous. It practically didn't change at all. So, mathematically speaking, when you have an object very close to you and you walk past it, its distance changes a lot very quickly compared to what it was before. When it's at a medium distance, it changes a little less when something is very far away. No matter how much you move, the distance you are from it doesn't change that much proportionally. If we think about the field of vision itself, about what you can see through the car window, that's exactly it. That thing, in a second, it passes by the car window and disappears. The mountain that's close takes some time because that distance takes a bit longer to change considerably. What's in the background? You can walk for a long time. It'll take forever to change. So much so that when we're walking during the day, we see the sun pretty much always in the same position. From here on Earth, the sun practically doesn't even move in the sky. Its slight movement is due to Earth's rotation, not your car driving this thing, where an object that's closer moves differently from an object that's farther away in relation to our view is called parallax. And a very easy way for you to see this right now is to put a finger in front of you like this and move your head from side to side. If you put an object right behind your finger, you can make it shift from one side of your finger to the other. This is it happening in practice. That's parallax happening exactly at the moment you're doing this experiment. Let's go to our final question. Why do our mouths chatter when we're cold? It's not just the mouth, right? The whole body shivers. It's a way for our body to keep us from dying of cold. And when I say dying of cold, I mean actually dying of cold. It's not just an expression. When our body gets out of its normal operating temperature, when we're too hot or too cold, our brain starts thinking of a way to solve that situation. When it's really hot, for example, one of the mechanisms our body has is sweating. Water starts dripping. Your body releases water onto your skin. That water, when it evaporates, takes away heat, and you end up cooling down a bit. When it's cold, you need another strategy. And one of them is contracting your muscles, and that includes the jaw. That's why we start shivering. But why does contracting muscles heat anything up? Our muscles, to work, they need energy. They consume energy from our body. This energy comes from the food we eat and the oxygen we breathe, okay? Those two things cause a chemical reaction that gives energy to the muscle. But in this reaction, heat is also released. When you move your muscle, besides turning that energy into movement, you're also generating heat. It's like a car with an internal combustion engine, actually, which burns fuel. And one of the side effects of that is heating up. So, in the end, your body's strategy is to make a useless movement, like constantly moving your jaw, shaking your arms, shaking your legs, just to generate heat that will help warm you up. Just so you don't forget, at the very end, in Book of Dinosaurs and Prehistoric Life, the link is down below.